I'm doing great. How are you doing?
Yeah, I'm good. Keeping
Uh,
busy.
first, Firstly, thank you very much for coming to my show.
You're welcome.
So I've gone through a profile. I can see you're Microsoft most valuable professional, also senior software engineer.
Yes, I am. I've been MVP for a few months. Just got my first award. So, would you like to find out more about the process and how I was nominated?
And also, I want to talk about your one decade of experience in IT.
Right. Okay. Yes. Um, so I have been working in IT for over a decade now. I'm a senior software engineer, as you mentioned. At the moment, I'm based in London, and I'm working for a company based in San Francisco called Empower, which is a digital bank. As a company, we specialize in helping people with a bad credit score to improve their credit score because in US it's a very big deal, but it's primarily US market that we work for. Because in other countries, in some countries it's a big deal as well, but not in many countries in the world. I never actually studied to become a software engineer. I do have a degree, uh, but my original bachelor's degree was in biology. I always kind of liked technology, so I did like programming. I did do some programming when I was a teenager. But when it was time for me to go to university, almost all of my friends were choosing computer science or related subjects. And as naive as I was at that time, I thought that because everybody is doing those things, if I graduate, there won't be any jobs left. So I chose something else, like the second best choice was biology for me. Then I went ahead and did master's degree in a subject called environmental informatics, which is kind of a mixture of environmental science and a little bit of computing, but nothing to do with programming. But I decided to teach myself how to code properly when I got a job after graduating, because in that industry the pay was very, very small. So I had a job where I had to have a master's degree to do that job, but I was getting paid less than a warehouse operator was getting paid locally. And that's basically, as boring as it sounds, that was the motivation for me to learn how to code. I was kind of lucky in that particular place because it had a team of software developers. So I started to volunteer to help them. And this is how I could combine my day job with coding practice. So I didn't have to, well, I did spend quite a bit of time outside work practicing my coding skills, but I had a chance to actually do it during the work as well. When I was confident enough, I just started applying for pure software engineering jobs. Not the jobs that I had, which was analyst, but I did some coding on top of that. But the actual proper software engineering jobs, and I managed to get one. And since then, I've just been working in IT and never looked back. So that is my story. This is how I got started, and this is how I'm keeping going.
You are from?
Sorry, could catch that?
You are from which part of the world?
So originally, I'm from Belarus, but I've been living in England since 2001.
So I can see you have done a lot of roles in your career in technology.
Yeah.
So after graduation, you started your education from biology, then your master's degree in environmental science, did a little bit of computing. Then you decided to come into technology because of the less pay that you're getting in other jobs.
Yes.
So how technology job and or role started, and with which technology you have started?
Mm. Right. Okay. So my first job after graduating was in a flood risk assessment firm. So my job was to build flood risk models. We were getting some data from satellites, from some historic records, combining it together and building a model. So if flooding will happen again, and in England it's a big problem, especially in the year when I graduated, we had a lot of floods in summer. Um, The job was actually very similar to writing software. It's not coding, but the process is the same. You build this model bit by bit. But because it was involved in technology quite a lot, we did have a software development team. And I started getting involved with them, started helping them, because they basically didn't have enough manpower to complete their own tasks. So I basically started combining my flood risk assessment work with some software development. But at the beginning, it was very basic, and no pun intended, the language I was using was basic as well. It was VB.NET. VB stands for Visual Basic. I started with .NET, and .NET is still my primary technology now, but I'm no longer using VB. I haven't been using VB for at least 10 years now. My primary language is C#. At the beginning, I did try to learn some other languages as well. I tried Java, went through some tutorials, even built some Android apps in my own time. I tried learning Go. I did JavaScript. I actually used quite a lot of JavaScript in my work. But I stuck with .NET because it seemed to be one of those technologies where there are plenty of vacancies. There's a lot of demand for it, and the pay is good as well. Because, for example, on average, if you are a PHP specialist, on average, you would be paid less than a .NET developer. Not always the case, but on average, it is the case. And yeah, in all these technologies, in all the companies that I worked for, it was primarily .NET, and to be more precise, ASP.NET. And then since 2016, it's been ASP.NET Core, because ASP.NET and ASP.NET Core, even though the name is very similar, actually two completely different things.
So what kind of projects you was involved in?
All sorts. So my first, after leaving the flood risk assessment company, my first company was FinTech. That company built a software that provided a combination of different financial tasks. It was a combination of it was like a tax calculator. Then it was a reconciliation, which was some accounting process. Some of the software that we built was bespoke. So, for example, we built a trading platform for a specific firm, but it wasn't an off-the-shelf product that we were selling to anybody else. After that, I went to a consultancy firm called CGI. It's a big multinational corporation with headquarters in Canada. They did some government projects for them. Then after that, there was a company specializing in electronic shelf edge labels. So it's like a Kindle, but you put it on the shelf in a supermarket. So instead of having a person going somewhere and physically changing a piece of paper with a price on it, you just press a button on the computer and it changes that picture on that label, which was quite a cool idea. Then I got kind of headhunted by a startup that was specializing in improving information systems at railway stations. That was a very interesting project. So basically, the company, the main product of the company was this full HD display that would replace standard matrix displays that you would see on many train stations across the world. Normally you would see a display that is black, and letters and numbers are just like yellow dots. We would replace them with full HD displays, so we could display animations and some other things. For example, so basically we could display literally any arbitrary animation, because we could just use any arbitrary HTML, JavaScript, and CSS on the screen. For example, if the train is due to split into two, which is a fairly common thing in England, we would show split animation on the screen. If a train is equipped with some AI technology to measure how busy each carriage is, we would display that on the screen as well. We would get the data from those sensors, and the passengers of the platform would know which specific spot on the platform to stand, because they would see on the display which carriages are busier than others. My specific role was to develop IoT technology. we had those devices. We would put a device on each platform, and each device had multiple roles. It was basically like a single board computer similar to Raspberry Pi, but more robust than a Raspberry Pi. But at each platform, this device would make announcements by using text-to-speech. Because traditionally, the way train announcements were made at railway stations, there would be some actor that would pre-record all the station names in advance. And then when the train arrives, this announcement would kind of be glued together. Sometimes there would be some new station names that they had to hire somebody else to record. Sometimes they couldn't do that, so they had to actually announce it with a microphone. Instead of that, to replace all of that and to make it dynamic, we did text-to-speech announcements. So we literally just construct a bit of text, send it to some server in the cloud, and then receive the MP3 back, and it would be able to pronounce any stations that new or it doesn't really matter. And we had some configuration similar to so for example, some train stations, the way you write them and the way you pronounce them are two different things. For example, in England, we have this town called Reading, but it's actually spelled exactly the same as reading. And if you just send that word to text-to-speech server, it will tell you reading. So to some stations, we have to apply these additional rules. There's a language called SSML, which is used by text-to-speech software. So we applied that. It was a really fun project. Another interesting thing about it was that because there are multiple devices, and sometimes trains arrive very close to each other, time-wise, on neighboring platforms. These devices acted as like one distributed application. So when one device is making an announcement, every other device in the vicinity would know about it, and they would hold off their announcement, so they wouldn't talk over each other, which was quite a cool thing.
So how many projects you have done in this decade?
How many projects? Oh, I've done lots of projects. I don't count them because as well as doing my main job, I'm also doing. I'm always involved in some kind of side activity in my spare time. For example, I've been producing quite a lot of educational content. I've been helping other people with their projects. I'm doing some live mentorship as well. So yeah, it's just too many to count.
So I can see you have done Microsoft MVP. So how was that?
Right. So Microsoft MVP is an award that you can receive if somebody from Microsoft or somebody who already has MVP spotted your work and they nominate you. So you cannot basically self-nominate. I don't know what criteria is exactly. I still kind of haven't figured it out. But you have to be fairly active in the community. You have to be producing a lot of content. And this content has to be of sufficient quality as well. So you can't just write some random tweets about .NET or any other Microsoft technology. It has to be this type of content that actually affects people, that people find exciting or useful. And then, yeah, as I said, it has to be an existing MVP or somebody from Microsoft that nominates you. I've been nominated because an existing MVP. I was basically involved in helping somebody who was an existing MVP to write a book. That person, Anthony Giletti, he's called. He was writing a book about gRPC in .NET, and I provided a technical review of that book. And then somebody else approached me as well about. At that time, I was writing my own book as well, and that book got published. And then another MVP approached me as well because they found that particular book useful. And so, yeah, long story short, this is how I got nominated for MVP.
And what you have learned in this 10 years of experience?
In 10 years, I've learned many things. Well, what specific things you want to know about?
Usually in technology in general, how much knowledge you have in technology, what you can do with the knowledge that you have earned.
Oh, yes. So in these 10 years, because 10 years is a long time, especially in technology. In technology, on average, what you're doing now is going to be, a lot of it is going to be obsolete in 2 years because it moves really quickly. So what I've been doing at the beginning of my career is vastly different from what I'm doing today. Like, for example, at the beginning of the career, I've been writing some extensions for desktop applications because back then it was one of the popular type of software engineering job. Today, I'm primarily specializing in distributed cloud-based applications. A lot of things that I learned during the process. At the beginning, as a beginner, I was just writing any code that would solve immediate problem. I wasn't aware of many best practices such as solid principles, dry principle. I would basically just output the code that works, and that's it. And my only goal was to make it solve that specific problem. However, over time, I started to understand why these principles exist. When you're working on some piece of code for a long time and then you have to apply new updates to it, it's very hard if it hasn't been written according to best practices. Your code shouldn't only do the job that it's intended to do, but it should also be structured in such a way that it's easy enough to modify if requirements change in the future. It needs to be maintainable, not only effective but also maintainable. Then over time, I've learned the importance of unit tests and test-driven development. Because to me, initially, the test was just the thing that, I didn't fully understand at the beginning. Why do you even need to bother writing unit tests if you can just, as you develop the software, can just write a piece of code, a test that is working, and you just ship it. But then over time, I actually realized why it's important, because in a big application, you can't always reliably tell that your change is not going to affect anything else. So if you have this coverage of tests, this will act as a safeguard. Not completely foolproof, but it will act as a safeguard. So yes, probably the first kind of transitional period which everybody goes through, from junior developer to mid-level developer, is understanding of why best practices are important. And then over time, the next stage of transition in your career is when you transition from mid-level developer to senior developer. This is when you start to understand why soft skills are important. And sometimes soft skills are even more important than hard technical skills.
And what is software and why we should develop it?
What is software and why we should develop it? So software is, computers are very powerful. Computers can do a lot of things much faster and with much better accuracy compared to humans. And software is the thing that makes computers do those things. So software is primarily an interface that allows us to outsource a lot of mundane or hard tasks to a computer. Why should we keep developing software? Because we keep encountering new problems all the time. So we still need to keep coming up with the solutions to these problems.
And how the hardware is connected with the software?
How is hardware connected to the software? So hardware is the stuff that does all the work, and software is the thing that tells the hardware what work to do.
And what is the best way to find the connection between software and hardware?
I'm not sure how to answer this question, to be honest.
You have worked on different applications in your life, which have
Yes.
which needs different software configurations, which needs
Yes.
different infrastructure on different uh, 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 platforms. So how a software uh, can be analyzed and can be developed in such a way that this software needs this particular amount of hardware.
how to develop software that is as efficient as possible.
Yeah.
With the hardware. Yes, this is what computer science basics are for. If you've heard people talking about data structures and algorithms, this is the fundamental knowledge. This is the reason why a lot of developers recommend those as the first thing that every developer should learn. I don't necessarily agree that those are the first things that every developer should learn, because I haven't been learning them at the beginning of my career. I only learned them later, and I was fine at the beginning of my career. But essentially, what these are, both data science, both data structures and algorithms, they're the ways of making your software as efficient as possible by using as little memory as possible and by utilizing as little computational power as needed for the task. For example, one type of algorithms that you may encounter is the sorting algorithm. So you have a collection of some numbers, for example, they're completely random, and you need to sort them to make sure that they're displayed in a particular order, from lowest to highest, or vice versa. If you just do it by brute force, just look at each number and compare it against any numbers that went before it. If it's smaller, then move it at the beginning. If you do this kind of thing, it's going to take you a very long time, especially if the collection is large. This is just a brute force approach without using any algorithms. What algorithms were designed for is to deal with these kind of problems. So it's like a mathematical way of either splitting it into smaller sets, going through this sets and combining them together, or doing something else. But essentially, this is how you make your software as efficient as possible.
So you have done work in developing different softwares. So how those architectures are designed, and what is the procedure for it? And also tell me, in this evolution, the technology evolution, the software development is also changing. Also, market is changing. The demands are changing. People are asking
Yes.
different ways of making a software. So how this evolution you define?
So evolution in software development primarily touches the level of abstraction that you're working with. So the first, the pioneers of software development, the first software developers were writing. They weren't writing what we call software. They were writing direct instructions for the CPU. It's similar to what we call assembly language now. So essentially, instead of writing the things that humans can understand, they were literally writing the things that only machine could understand. That is the kind of the lowest level of abstraction you can think of. Then some programming languages were invented, and software started to be written at higher level of abstraction. What you are writing now is readable by humans, and once you press the compile button, those instructions that you've written in a programming language get converted into CPU instructions. So you are no longer writing CPU instructions directly. You are now writing software at a higher level of abstraction. And evolution basically goes this way. Every step in the evolution of software development, you're just dealing with higher levels of abstraction. The next level after that, so for example, the second level of abstraction, it's medium level languages like C, C++, where you have to manage your own memory, those kind of things. But when you look at the code, it's human readable. You can understand the code. While when you're looking at direct processing instructions, it's very hard to understand, especially if it's a complex software. Then the next level of abstraction, languages like Java, JavaScript, C#. In those languages, there are a lot of background processes that do things for you. You no longer have to manage your memory. The code is nicely readable, stuff like that. And now we are in the stage where a new level of abstraction is being developed, AI programming. And as I say to people, AI will not replace software engineers. It's just another level of abstraction. You still need to be knowledgeable enough to know what to ask AI to do in order for AI to be able to do it. So just like, for example, a lot of people back in the day were saying that with the invention of Google, you will no longer need software developers because anybody can Google how to write this particular piece of code. It never happened because in order to be able to find out how to write this particular piece of code, you need to know what to type into Google. And it's the same with the AI now. But the only difference is that Google only gave you the answers, but the AI will give you the ability to write the whole piece of software, the whole module, just by typing some requirements in. But you still need to know how to type those requirements in. You still need to ask a question specific enough to get a good software out of it.
So how ChatGPT is helping software development?
At the moment, I would not recommend to use it for software development because it can develop some code, but it doesn't mean that you should use it. Because at this stage, ChatGPT is nowhere near accurate enough. I don't know if you've seen this cartoon. Like back in the days, it used to take like 6 hours to write a piece of software and 20 minutes to debug it. Now with ChatGPT, it takes 20 minutes to write a piece of software and 24 hours to debug it. Because sometimes the code that it produces is wrong in a subtle way, in a very subtle way. It kind of looks correct. And it takes you like, especially if you rely on it to produce complex pieces of code, it may take you really, really long time to find the mistakes in it. The same with text. I used the ChatGPT to write the so-called boilerplate text. I never used it for coding myself. I do sometimes you use it just for fun, just to see what the output would be in coding problems. But I use it for the so-called boilerplate text. Like for example, when you have to write documentation, those boring type of writing that you probably don't want to do as a human anyway. And almost every time I have to go through the text. Well, I always go through the text afterwards, and almost every time I have to correct quite a bit of it.
And how artificial intelligence is affecting software development?
At the moment, it isn't. But in the future, basically, when artificial intelligence will be more advanced, people who don't use artificial intelligence will be left behind. So it's not that artificial intelligence will replace software development jobs, but I do believe that those software developers who use artificial intelligence will replace those software developers that don't.
And you might have worked on different softwares and in developing in that. So how the humans are thinking when it comes to softwares? How they are thinking that the software can solve our problems and can reduce our mental, physical energy or effort.
Well, the thing is, the software is everywhere, so it's a very it cannot be answered with a simple answer because software is now literally used for solving all sorts of problems and improving lives in many different ways. Expectations from the user have been changing quite a bit. For example, these days, because internet is so fast and our devices are so powerful, like for example, a smartphone of today is more powerful than a desktop PC of 10 years ago. More powerful types of software can be supported. Like for example, now almost everything can be done just in the browser. About 10 years ago, it wasn't possible just because of the network, hardware, and limitations. These days as well, there's a new type of relatively new type of apps called progressive web apps. It's where you can basically take a web page and download it as an app on your mobile phone directly from the browser without going through like app stores. I expect to be seeing more and more of this. On Apple devices, it's more difficult than on Android devices because Apple devices have so many restrictions in place. But yes, I would be expecting to be seeing more seamless integration between desktop and web applications.
And what changes that you're observing uh, uh, in the architectures of the softwares?
In the architecture. So I think we went kind of in a bit of a cycle. For example, about 10 years ago, everybody was talking about microservices, distributed applications. It's still the case today, but now more and more people realizing that monolithic applications actually serve their purpose as well. Architecture-wise, serverless is becoming bigger and bigger. So serverless is basically something like Azure Function or AWS Lambda. It obviously has a server because everything needs a machine to be hosted on. But it's called serverless because as a developer, you don't care about the server. It's somewhere in the cloud. You don't manage the hardware at all. You rely on the cloud provider to manage it for you. And it's elastic. It's completely stateless and it's elastic. By stateless, I mean every time you use it, it gives you exactly the same result with exactly the same inputs. It does not store, well, it might give you different result. Like, for example, if you request current date time, it obviously will give you different result. But the point is that it does not remember what happened before. And because it's stateless, if you rely on it for particular calculation, for example, it can be also elastic. By elastic, I mean, if you are bombarding this application with many requests, many new instances of this application get spawned out. So it basically scales out to be able to deal with these requests automatically. And then once the number of requests gets reduced, the scale of the application goes down as well. And it's a very good model in terms of costs as well, because you're not paying for the hardware, you are only paying for the computational power when you use it, and you are paying as much as you use. You don't have to have virtual machines like on standby all the time. So on the server side, I'll be expecting to see more and more of this. I'm using it quite a lot in my work, and so do many other companies.
And what is the difference between hosting software in their own data center and hosting software in cloud?
There are pros and cons of each approach. Software ultimately is always hosted in some kind of a data center, even when you host it in the cloud. It's just that data center doesn't belong to you. So obviously, when you host in your own data center, you have more say of what happens to it. You have more control over it. You have more control over privacy, everything else. But there are downsides. Obviously, you have to manage all this hardware yourself. You have to buy the hardware. If there's a problem with the hardware, there's nothing you can do. With cloud, you don't bother with any of that. You basically deploy it somewhere via very nice visual in-browser user interface. And it's the owner of the data center that manages it for you. It's got some geo redundancy. So, for example, if that particular server rack catches fire or just breaks down, your software is not going to be affected because it's geo distributed across many different servers, and you don't even care about it at all. The disadvantages is that it might actually be more expensive sometimes, depending on the scale of the software that you host, and also you don't have full control over it. In theory, companies like Amazon, Google, Microsoft, they do guarantee data integrity, security, and everything else, privacy. But there's no way you can verify all those things. I'm not paranoid. I would trust them, but for a lot of people, it's an issue. And this is why, for example, companies in defense or industries that require strict privacy sometimes refrain from using those cloud providers and prefer to self-host services.
And what is the future of data centers?
There's going to be more of them because, the cloud uses data centers. So basically, cloud is lots and lots of data centers. So yeah, I'm just I would say that there's going to be a lot more of them.
But compared to previous years or previous decade, the software development uh, has been increased. The percentage has been increased. Many softwares are coming into the internet, and those are distributed in different cloud platforms and in different data
Yep.
centers. So if these softwares are distributed in multiple data centers, in multiple servers, and multiple softwares from multiple countries, and that's my question is, what is the future if a software is distributed in multiple times in multiple servers? Do you think that cloud providers are going to benefit from this?
Of course. Cloud providers are the ones who build those data centers primarily. Not all data centers are owned by cloud providers, but the ones that are owned by cloud providers, they're like these mega data centers that they may occupy, I don't know, a square kilometer, for example, like just all server racks. Like in US, they are building those mega data centers in Nevada desert and some other places. Yeah, I'm just seeing that it's going to be more and more of them. They obviously would require a lot of power as well. So I would imagine that we will require to build new and more powerful power stations to supply all these data centers with the power. Probably quite a lot of power supply is going to be funded by those companies as well, which they already are funding some of them. So, for example, that mega data center in Nevada desert is powered primarily by solar power that the cloud provider has actually built next to it.
So what you have understood totally about software development?
What I understood is totally about software development. As a software developer, you primarily need to think of yourself as a problem solver and not as a specialist of a particular programming language or a particular framework. Because if you think of yourself as, I don't know, if you say I'm a Java developer or I'm a C# developer, then you're kind of conditioning yourself not to be adaptable to the changes. But if you think of yourself as a problem solver, then it doesn't matter how the software development industry evolves, you will always find your place in it. For example, this attitude helped me to transition from environmental scientist, like flood risk analyst, into a software developer, because to me, it was the same thing. It was just a different type of problem solving. And because changes are happening fast, I think people who will thrive in this industry are the ones who will adopt this problem solver attitude.
And what advice or suggestions you will give to the software developers for watching and listening to you right now?
So one of the biggest problems that software developers face is called imposter syndrome. Like everybody goes through it. Imposter syndrome is when you believe that you are not competent enough. It's basically when you think that other people that you are working with are much more knowledgeable and much more competent than you are. And a lot of people think, because not everybody talks about it, in the last couple of years, people started coming out about it more. And it's kind of, it starts to be understood more and more as a normal thing. But yeah, it's essentially what I would advise to, the advice I would give to any developer, and especially a new developer, is that what you are going through, this experience, is normal. Everybody feels imposter syndrome at one stage, well, like at any stages of their career. I am a senior developer with over a decade of software development experience, and I sometimes feel like an imposter as well. It's absolutely normal. I've learned how to deal with it, and basically what helped me to understand that it's not really a problem is the fact that when I got to know how many different programming languages, technologies, libraries, frameworks, etc. are out there, you just realize that it's impossible to know it all. So if somebody knows something that you don't know, it's not because they're more competent than you are. It's because they learned that thing. But as an experienced developer, there ought to be some things that you know and they don't know as well. It's a normal process. So yeah, if you feel like imposter, it's normal. Don't forget about it.
And at last, what is your observation about my work? Have you seen any videos of mine on YouTube?
Yeah. I briefly watched a couple of interviews. Like for example, the latest one I saw was with Amazon AWS evangelist. I think it's the latest video on your channel. Yeah, it's really good. Yeah, I'm really happy to support your work. I see that you are growing your YouTube channel. It's a really good content and quite a lot of it as well.
And I did masters in software engineering, also bachelor's in computer science and engineering. Right now I'm doing DevOps engineering work. So that is my full-time job. Apart from that, I'm taking interviews of different experts from different parts of the world who are into IT industry for 5 years, 10 years, 20 years, 30 years, 40 years, 50 years, uh, and working in different projects and solving different problems and from different parts of the world. Apart from technology, I also interviewed people who are into film industry, who are lawyers, advocates, doctors, authors. So I'm doing this, trying to connect with the world with by trying to know their experiences and how they have solved the problems in different industries, not just in technology. But mainly my work is technology. I do a lot of technology interviews. So how this interviews, this content creating and talking with experts like you, asking questions, how this experience is going to helpful for me if I work in IT in coming days.
How this experience will help you? Well, first of all, you are getting access to people for face-to-face conversation. It's similar to mentorship. I do some mentoring, and I can just see that some of my mentees improve really quickly. When you have a conversation with somebody face to face, you get knowledge delivered to you much quicker. Plus, you are asking that person targeted questions, so you can get expertise or some opinion on something that is important to you. Second thing, which is a very big point as well, you are building your personal brand, which is very good. I do too. I haven't posted anything on my YouTube channel. I haven't really been growing it for years, but I do post quite a lot of content elsewhere. In your case as well, because you are talking to different people, all sorts of different people, you are developing your soft skills. Potential employers will see it. You will be more likely to consider for promotions as well. You will be more likely to consider it for managerial positions as well when people see the content that you are doing. So yeah, it's going to help you in many different ways.
It's a great and valuable feedback for me. Definitely, I'll keep this in my mind.
Yeah.
And uh, can you share your content or what you do to help to the technology world?
Yes. So what I do on in my spare time, I'm active on a platform called mentorcourse.com, where people can book me for live mentorship. I used to produce some courses on Udemy. I don't do that much of that anymore, but I do now produce courses for various educational institutions. So, for example, there's a company called educative.io. I've done a couple of courses for them. It's a very useful format. So it's basically a text-based course, but it's fully interactive. So you can build application right in the browser without having to download IDE, do any of those kind of things. It's like a book, but you can practice what you've read about right away, which is really good. I really love the concept. Yes, so this is pretty much the main activity that I do outside my main job now. There is also a website that I have. It's called scientificprogrammer.net. I do occasionally update it. I used to write more on this website, but Lately, I haven't been doing that much, maybe like one article per month because I've just been too busy doing other things. I wrote a couple of books. I am actually working on a book right now as well. I think it's 6 now altogether. Most of my books were self-published as well, which is quite cool. Publishing books helped me a lot because my current employer found me because I posted about publishing a book. So that helped. Well, and as I already mentioned, my books helped me to earn my MVP for Microsoft. In fact, that's maybe a whole topic of its own, like self-publishing books as a software engineer. How can that help your career? But there are so many different tools now that allow you to self-publish a book, and not necessarily just ebook, but a full like printed book without contacting a publisher at all.
And can you tell me about your books that you have published? What it is about and why?
Yes.
What is your motivation to write it?
My motivation was primarily I started doing this in the educational content, like teaching other people initially, because I wanted to learn certain technologies in depth. And I was always a believer of if you try to teach people this technology, in the process you will be kind of subconsciously made to learn it in depth. That was my main motivation initially. And after that, after I've been invited to write a book, because I didn't start as a self-published author. I started because a company called Pact approached me and they asked me to write a book about a particular technical subject. And then while I was waiting for this book to be published, I've submitted all my drafts, they were approved. I just needed to wait for this book to be published. While I was waiting, I decided to explore how easy would it be to self-publish a book. And so I did it. Like I wrote a book in 2 months because, with modern tools, you can write books relatively easily. I just took some content from one of my old courses, updated it. So I already have all the code samples, and this is why it only took me like 2 months to write a book. It was about a technology called Signal R, which is specific to .NET, but it allows clients to communicate with the server in real time, like 2 ways. That book did really well. Like in the first month, I made a couple of $100, and that it just became addictive. So for some time, I've been writing books just because it was kind of fun things to do. And yes, since then, I don't think there's ever been a period when I wasn't writing a book, to be honest. As I said, I am in the process of writing the book now as well.
So you told only about one book. You said you wrote many books.
I think it's 6 altogether. So one of them, the first book that, not the first one that was released, but the first book that I started writing was about a technology called gRPC and its implementation on .NET. Then while I was writing this book, I was approached by some software development blogger called John Sonmez. He has this site called simpleprogrammer.com. I wrote a couple of articles for this website in the past, and I've been approached by one of his assistants to see if I would be open to write a book. And I wrote a book. So basically, John agreed that I should, and I wrote a book called Battle Hardened Developer, which it's not a technical book. It's a book about various productivity tricks, how to stop procrastinating, how habits are built. So it's more a book about psychology and like mindset. But it's written in the context of software development. So the main audience for that book were software developers. And that book became an Amazon bestseller in software development category and held this position for about a month or so. So yeah, it was quite a successful book. And that was actually the book that I'm most proud of. Because it's not about specific technology. It's actually targeted to help as many developers as possible. And not necessarily developers, but like any knowledge workers, because the information that I put in this book is applicable for any type of knowledge work. All those things are the things that I've learned from reading psychology, and also some tricks that I practiced myself that worked for me. Like for example, to fight procrastination, one of the things that you can do is split your task into micro tasks. And while you're doing like a particular micro task, just think about that micro task and forget about everything else. Yeah.
So if you can send me all your web links, I'll put in the description of this video on YouTube, also on the screen as well. People who find our video on YouTube can see the work that you're doing, can learn from you. And
Yeah, sure.
also,
I'll
and
appreciate that.
also, and also I'll put your links on my website as well. People who finds my website on the internet can see, who visits my website can see your work and can learn from you.
That'll be awesome. Yes.
Can I put this video on my YouTube channel with your permission?
Absolutely. On YouTube channel, anywhere else, anywhere you want.
Yeah, that's my next question. Can I put this video and audio clip on my podcast, website, internet, social media, everywhere with your permission?
Absolutely everywhere. Yes.
So keep going, keep inspiring, and keep learning, uh, also because of you, I'm sure a lot of developers will get inspired and learn from you.
Yeah. You too. You're doing some really great work. Keep doing it. I'm pretty sure that your channel is gonna grow quite quickly. I will share this video with my audience as well.
It's an honor you saying me that being in technology industry for 10 plus years and working in different projects, working for different industries, you saying that word about my work, it means a lot to me. It's so valuable for me.
Because it's really good. It's genuinely good. The amount
Thank,
of really good content and the people that you spoke to in your channel, I think more people should know about it.
thank you, sir. Thank you. Thank you very much. Keep going, keep doing what you love.
You too.
Yeah. Take care.
All the best. Take care.
Bye.